Now see here, refraction at a spherical surface. Again from the beginning. This is air medium. This is glass medium. A tensile medium. Okay. Now this is the, so we are drawn because we have taken a dotted line here. This dotted line means is a thin lens. Is a thin lens. Now this is normal. This is a normal which passes through center of curvature. Now this is the incident. O is the object, I is the image. O is the object, a point object. We are taking only one ray here. So it incidents at the point N, then it refracts and forms the image at I. And the angle of incidence here is, and not angle of incidence. We say this is the angle made with the principal axis. This is alpha, and this is beta, and this is gamma. And U is the object distance, V is the image distance, R is the radius of curvature. Now, rectangle triangle NOM equal to tan alpha equal to opposite upon adjacent. Similarly, NMC or NCM. So that is tan beta equal to opposite upon adjacent. MN by MC. Third one, right angle triangle NMI, tan gamma is equal to MN by MI. Okay, these are the three triangles, three angles. Okay, here our refraction angle we have to find out. This is angle of incidence. This is angle of incidence, and this one is angle of refraction. Here, angle between the refracted ray and the normal. This is the angle of refraction. Angle between the normal and the incident ray is angle of incidence. Yeah. Now. So therefore, exterior angle is equal to sum of two interior opposite angles. Okay. Exterior angle is equal to sum of two interior opposite angles. So that we will do that. So here I is the exterior angle here. I is the exterior angle. I is exterior angle. I is exterior angle. This angle will be equal to these two angles, alpha plus beta. So I is equal to what? I equal to alpha plus beta. If you take the other triangle, what is that? NOC. Okay. Now. So now I is equal to how much now? First we will calculate I. I is equal to how much? I is equal to, we have alpha. How much is alpha? Mn by Om. Because angles are very, very small. So we are writing alpha. This we are writing beta. This we are writing gamma. Because angles are very, very small. So alpha is Mn by Om plus beta is Mn by Mc. This is the value of I. That is common out. Yeah, we can take. We will take later. Let this be equation number 1. Did you bring the numericals? It's there on the WhatsApp. We will do it. Okay, after this. Now, R is equal to how much? Similarly, R is equal to. So, want to find out R. R is equal to NCM. NCM. This beta minus gamma. To find out R, you have to just subtract both of them. Beta is more, gamma is less. This may be 60 approximately, this is 30 approximately. So we are just subtracting both of them. Then what is again beta? Beta is equal to what? Mn by Mc minus Mn by Mi. Okay. Mn by Mi. This is equation number 2. Okay. That is equation number 2. Now we will use Snell's law. What is Snell's law formula? Snell's law formula is mu1 sin I equal to mu2 sin R. Okay, mu2 sin R. So we will write here mu1 by mu2 equal to, or we can write directly like this: mu1 into I equal to mu2 into R, because angles are small. Just substitute now the values. Okay, substitute the values in the place of it. Now, what is I here? Mu1 into I. I is how much? Mn by Om plus Mn by Mc equal to how much? Mu2 into R. What is R? Mn by Mc minus Mn by Mi. Okay. Now take common. Mn common on both the sides. Cancel it. So I am not going to write the step again. Okay. So mu is equal to how much? Mu is equal to 1 by Om plus 1 by Mc equal to mu2 into 1 by MC minus 1 by MI. Okay, 1 by MI. Is this clear?
Yes, sir. Like multiply them both.
Now multiply with N1. Or can I write N1 instead of mu1, mu2? It will be easier for you. Yeah. Now here I am taking here N1 by OM plus N1 by MC. I have taken N1 as mu1, okay, and N2 as mu2. Now which is equal to what? N2 by MC minus N2 by MI. So we'll put MC together. So what it will become now? So N1 by OM plus N2 by MI, which will be equal to N2 by MC minus N1 by MC. So what is OM now? OM equal to U minus U plus U? Minus U. Yeah, according to sign convention. Now, what is MI? Is V. What is MC? That is R. So therefore just substitute here N1 by minus U. Can I write directly for N2? N2 by V minus N1 by U equal to N2 minus N1 by common denominator by R. Is that clear? So this is the formula for the
Bearer to density.
yeah. Bearer to density. N2 by V. Sorry, this is N2.
That's it.
Yeah. So this is the formula.
That you need to put minus U over
Minus U.
minus U.
Minus U.
You know, almost also yeah.
So I'm very used to go here.
Yeah, fine. Yeah. Yes, ma'am.
Thanks, sir.
We already did yesterday, right? We already did this
Yes,
yesterday.
sir.
I was expecting you will be 9 here will be here.
So he was sleeping till 10.
Yeah. How did you come actually? Who dropped you?
The bus.
Yes.
I took bus by 10:15.
No, you came so fast.
Came around 45:50. And there was no traffic.
Okay. So we go to the next. Clear? Read out. You have to practice
I was
this.
so tired.
There will be a test next. Mr. Raman, there will be a test next week.
Yeah, test the board also.
So,
I can fill in that.
I'll give you derivations. Read derivations. You have to do this. Okay. And the microscope telescope. I'll give the questions in advance. Prepare and comment. Numericals, that I won't give. Okay. Questions, derivations you take in advance. Prepare and comment. Okay.
Microscope.
1 second. Let me do one more. 3 are there, no? One is
Lens make a formula.
lens make a formula.
Refraction.
Then prism thing is there. Then microscopes and telescopes.
Compound microscope and simple is it?
Simple is also.
All
Simple
have same,
compound.
all have kind of same diagram.
Same.
Telescope is there?
Telescope is there.
Hmm?
Yeah. What should I say now?
I do.
The syllabus. They have given both reflecting and refracting. Both are there. In that one is remote, I think.
God, many.
Terrestrial is remote, I think. Terrestrial is remote, but in astronomical there are two. Cassegrain, that is reflecting one. Refracting is also there, reflecting. So there are two actually. Reflecting and refracting.
Prism or lens include.
No, let me just one derivation I missed. Okay, that is about the relation between relation between critical angle and refractive index. Refractive index. Okay, so what is the formula here? We have mu1 sin I is equal to mu1 sin theta 1 mu2 sin theta. Now, the medium light is traveling from denser to rarer, right? So denser, this is denser medium. This is mu2, mu1 and mu2. This is theta 1 and this is theta 1. So here theta, I am taking air. This is 1 because this is air. Okay, I have taken this as air, and this is theta 2 is 90 degrees. Theta 2 is 90 degrees and theta 1 is C, critical angle. So mu 1, I'm just writing mu 1 is equal to mu. Okay, only 1 medium. Mu is equal to mu into sin theta 1. While what is sin is C is equal to mu 2 is 1 and sin theta is sin 90. Sin 90 value is 1. So therefore mu sin C is equal to 1. So mu is equal to 1 by sin C. This is a relation between the critical angle and PIR. Okay. This is very important. Now also suppose sometimes he will not ask like this. He will say sin inverse. So sin C is equal to what? 1 by mu. C is equal to sin inverse of 1 by mu. Okay. So this is one of the small derivations. Okay. Suppose what he will do, how will he confuse you in the numerical ability? He will not take air medium. He will never take air medium. This is only possible for air medium. If it is from glass to water, example, in that case 2 also you have to take. So you have to use this formula. Just start out this formula. You have to use this formula. Mu1 sin theta 1 is equal to mu2 sin theta 2 when it is glass to water. In that, suppose I am taking one example. Now this is glass and this is water. Now here it is C, okay, and this is 90 degrees. Example, glass is, let it be 1.5 and this is 1.33. Okay, so mu1 sin theta 1, mu1 is 1.5 into sin C is equal to what? Mu2 is 1.33 into sin R, sin 90 degrees. Okay, now what will happen? Sin C value is how much? 1.33 into 1 will become that much only. So C is equal to what? Sin inverse of 1.33 by 1.5. You have to solve in this way. If you go with this formula, you are gone. Answer is no.
So by then board will give you some marks for writing all this
Why?
stuff. It's needed.
The diagram on
But then our school won't even mind seeing it.
Numerical, there is
Yeah, it's a straight
no
formula.
mark for the
It's
diagram.
Yeah.
It is right, that is okay.
Yeah,
So
you don't
derivation
see
is
what
okay.
you write, then it's want the answer.
This is possible there. 4 months will be 0 or 4.
You know.
Yeah, got it. So go ahead now. Go with the next derivation, that is reflection by lens. That is lens spectrum formula. We are going to do now.
And now
Vivad, are you understanding? Mr. Vivad?
So compare that question to
Yeah.
case of
You want to have tea, coffee, something? So there are so many cafeteria and all. You can order. Please, fine. Now, so we'll go to the next one, refraction by lens.
Now, example can walk it.
Now,
It's good. So this is the equation where we compare the equations, right?
yeah, there are two normals. Okay, one this end, the other one is end.
Yeah.
Okay, two normals. Here, This is A, this is B, this is C, and this is A, B, C. Two curvatures. This is the first diagram. The second diagram, we are taking only air and glass. This we are taking air, and here it is glass.
I'm seeing what how to do this.
So this is normal, which passes through the center of curvature. C1. Now this is B. So what happens? The image is formed here, I1. Okay, image is formed at I1. Radius of curvature is what? R1. And the refractive index is N1, the refractive index is N2. Okay, so we have A, B, C. This is curvature ABC. There are two curvatures, okay, ABC and ADC. Two curvatures. So C1 is the center of curvature of the lens. Now, the third diagram. We are taking like this. The third diagram. So now,
So, but then in derivation, it's only fine if we draw one, right? The first one.
again half mark for each.
Yes, you got it.
If you draw that, you ask me. You have to draw the diagram, yeah, you will get marks.
No, only if I draw only one, the first one.
So then they want to do this one.
Yeah,
Derivation. So it wants to zoom this derivation.
In this exam, in your
there is one derivation, but then not like.
This comes up to
Oh, this is the easiest one.
this is the
That is like we need to make angles now. Oh, yeah, no angles are required. We already know the formula you applied. This already gets it.
no. So here,
You see.
the image is actually the actual image was I here, but I1 is the image here. This is the I1. That means the image for this diagram is object for the next diagram. Image for this the diagram is acting as an object for the next diagram. Okay. So can I take like this? So you can, yeah. It goes like this. About the normal. Okay. I'm taking because already this I is there already. I is there here.
Okay.
That I have taken here. I1 I have taken from this diagram. Yeah.
But then I1 is being formed inside the glass.
Yes.
It's not inside the glass.
So from air to glass, right?
This is air. No. This is glass and this is air. Here it was air and glass. This is glass and air. Only to that limitation. The limitation is only when until that time only when we are making it glass.
I don't know.
See here, there is air glass. We have taken this for some time. You forget that there is air here.
Yes, sir.
Make it completely glass.
Exactly. So it's fully glass, right?
Glass. Yeah.
That means I1 is inside the glass area.
Inside the glass. Okay.
That
Understood.
means the third diagram,
Yeah.
I1 should be like in the left side inside the glass area.
Yeah, that's what we are taking, but we are not saying in that way. What we are saying is this is the imaginary one. I1 is the imaginary one. That's actually not required also. I1 is imaginary one. If I draw here, where will you draw?
So there,
It will be like this?
yes, sir. Somewhere there.
No, because see this is
Angle can't be that.
because again you have to draw this side of the glass to make like no.
Yeah, but then the angle won't be that much inside.
That
So
much-
they will
Yeah.
go to the center of the.
As you said, sir, this should be in the glass.
Then how does putting I1 here like that?
I1, I am not changing the distance of I1. I1 anyways I am not using also. I have to do my area is O, I and C. That's it. I have nothing to do with I1.
Yeah, but then I1 is the object for the third diagram, right?
Yeah, object for the third diagram. Even if you don't take also, you will get the answer. Understood? Even if you don't take I1 also,
I don't get it.
no, if you don't take I1 also, this is the I right.
So no, it's the object here.
So just I am taking the extended thing. You think that as it is, I have taken here.
Like this.
You understood?
So but like where is the object for the third diagram?
Object for the third diagram. Okay, so what I will do is this I1 here,
Yes, sir.
this I1 is here, right? So what I am doing is I am making an imaginary one.
1 second, sir.
I am taking an imaginary one.
Okay.
I1 is a imaginary object. You think for some time it is an imaginary
So
object.
the imaginary
Virtual
object
object.
come there.
Virtual object.
And just
Think it is like a virtual object, not the real object.
Okay.
Understood? It's a virtual object. And this is the image, real image. I1 is a virtual object and I is a real image.
Yeah, okay, I can see that.
Got it now?
Yes, sir, I understood that. So then how does putting I1 there even matter?
No
this
problem.
is how it
Once the
works.
derivation will start, you will understand. Why did we take it out?
They come in. Okay.
Now.
Bend.
Okay, we'll go.
Again, we'll
So
come.
here,
That's it.
so I'm taking the first one.
Like this, like a glass slide. So this is the only thing which you make it as a point.
Now I'm taking ABC first.
That's it. Another one.
Yeah.
So I'm taking the ABC. So for the second diagram. Okay, ABC of the second diagram. So what is my formula? N2 by B
Axis.
minus N1 by U equal to N2 minus
And then we go,
N1 by
yes, and then we go more down. Right? That is the I1 is here. But then how does I1 come here?
No, listen.
See here. No,
But
see,
suppose
okay,
we
no,
have
no.
one
See,
that
his
much, right?
question is correct one. Suppose this is there, no man.
Yes, sir.
This is the object, no.
The lens
Wait,
is
wait.
actually over here.
This is the image form, right?
Yes,
In the glass.
Yes, sir.
Now this image, think that this is the object. This is the object.
Yes, sir.
But how is the other part? This is the part, right?
Yes, sir.
Where is the image form?
So
This is which, what type of surface is it?
one cave.
Cave.
The convex from say.
Convex surface, right? Convex will be like
lens,
this.
sir. Oh yes, convex. The whole thing is concave.
Concave.
So this
So it
one
will be
part is
imaginary.
concave.
Wait. It will be like, it won't get straight. How it will be now? For a concave surface, suppose the lens is like this, man. The object is here. Where will be the image form now?
Here.
Actually, what happens? You are taking it like this.
Yes, sir.
Understood now? So we are taking this as object I1 now.
Ah, okay. I see, sir.
Understand?
No, understood. So that's just too complicated. Just put the I1 there.
That's what we are not trying to explain all this story. But understand? Now, so
Explain this.
now here we have N1, N2 by
Silicon.
what is V here? The first, second case.
No, I cannot say.
What's this?
In this case,
That's the
no, this is not required. We are taking this.
one have that
V is
one have that distance. It will be over
OB,
here. Now this one is from
VI1,
But
VI1,
it won't come here. It's just
VI1.
thinking.
I have taken in this because I don't want to write minus before.
It is there.
Okay. So minus N1 by U. U is how much? Minus OB. Minus of minus plus. That is equal to N2 minus N1 by N2 minus N1 by R. R1 I am taking. Okay, N2 minus N1 by DC1.
So
DC1. Let it be DC1. This is equation number 1. Similarly, I am going to the next triangle. What is it? CA. What is it? A B C. A B C. Third one. Okay. Third formula again. N2 by image. What is image? DI1. DI1 plus. Both are in the same direction, right? So it will be di equal to how much? N2 minus N1 by R. What is R? Yeah, DC2. Should be center of curvature should be there somewhere.
Left side.
That side. Yeah. DC2. Yeah, can we take like this?
Yes, sir.
So I'll take DC2 here. Yeah? Yeah? This is image distance, right? This is image distance. This is object distance. Got it? Are you understanding this? But
Motor for generator.
This is not a school.
You need a DC motor to make this generator.
Can make it, but then we have to modify it.
You just spin the phone, yeah.
Yeah.
You need a DC motor there. Just not done. You're using electricity to make electricity.
So that we use, instead of using electricity, we use electron. But DC.
You still do it with your generation system. You more of the rest of.
So the best one is the water pressure.
Okay, now this is let this be equation number 1 and let this be equation number 2. Okay. So what we will do is we'll add both, and also we know that bi1 will be equal to di1 because b and d are the same because thin lengths, right?
Yes, sir.
So we are using this bi1 is equal to di1. So we'll add both of them now. Okay, equation 1 plus equation 2. So what we will get? N2 by bi1 plus n1 by ob plus n2 by di1 minus n1 by di1 equal to n2 minus n1 by gc1 plus n2 minus n1 by gc2. What we said? bi1 and di1 is same, right? bi1 and di1 is same. So anything will get cancelled here?
Yeah. So you can take di like
N2 will get cancelled. N2, yeah, this will get cancelled. Why this is plus?
So minus d minus n1 by d.
This should be
That's the
sorry. This should be positive and this should be negative, right? This will get cancelled.
So how to cancel different denominator?
This is di. Wait 1 second.
That's n2 by bi and n2 by bi. How do you cancel it? So it can be n1 minus n2 by di.
N2 by minus this should be minus and this is plus actually. Yeah.
Both should be positive. Both should be their sign. Why what should
N2 by n1 by minus. So according to this both are positive. In this case, one is negative, right?
First is
Oh no. Second medium is here and first medium is here, right? We take N2 then N1 here.
oh yeah.
N2 and N1 we take. Yeah, it's correct. It's correct only. See, in first case, this is okay. Once again, this is N1 and this is N, right? Now this is N2 and this is N1.
Oh, okay.
There we made a mistake. Yes, Mr. Sajid.
It's like all it.
N1 and N2. This is N2 and this is N1.
Yes, sir.
Because of that, we got error. So N2 and N1. So what do we get? Minus N2 by di1 plus N1 by di. Okay. So we get this terms will get cancelled. di1 and di1 will get cancelled. Only N1 is remaining now. So what are remaining? Should I remove this one?
By how you need to know the formula. Then substitute. Wait, answers.
Wait.
What can after this?
No.
This one is this one.
So N1 by OB plus N1 by di equal to N2 minus N1
And then there's
into 1 by BC1 plus 1 by
And then from here,
BC.
one common point one down here.
That will be equation number 2. Now we know that when suppose when the object is at infinity, there is a mid form
to make it
at focal point. Okay. It will form at focal point. Bi is equal to F. So N1 by F equal to N2 minus. So this will become 0. 1 by infinity will become 0. N2 by what is that? OB is equal to infinity if I take 1 by 0 will become 1 by infinity will become 0. Only this is remaining.
So instead of taking OB DI, it's better we take UB.
So
That makes easier because it's become complicated.
So it's just like 4 or 5 lines. It's simple here.
Yeah, the same thing, but instead of that one, you want U and V.
Yeah.
We can do that also. We will do that also. So 1 by BC1. Okay, so 1 by we'll get 1 by BC1 and plus 1 by DC2.
Yeah, where is that?
F is we have taken.
One by one.
If the object is at
Yeah.
infinity,
Yep.
image will be formed at
This is
Yes,
like
focal
I
point
did it by myself, but this is
So,
the explained one.
we
what
get
ma'am-
BC1
ma'am was ma'am wrote.
equal to R1 and DC2
No,
will be
no.
minus R2.
One by the minus one by
Okay.
one by
Minus half.
Yeah.
We'll take out the word, we'll do the same thing.
I didn't write it because I didn't.
No.
This is a detailed one.
So when we substitute in the formula, it will become what? N1 by F
So V is an
equal to N2
V
minus
is a-
N1
Yeah.
into 1 by
goes infinity.
R1 plus minus 1 by R2. So cross multiply this 1 by F is equal to what? N2 minus N1 by N1 into 1 by R1
Tomorrow will come there, so that-
minus 1 by R1.
We'll do.
So now just cancel the term. You get 1 by F is equal to what? N2 by N1 minus 1 into 1 by R1 plus 1 by R1. Sorry, 1 minus 1 by R1. So what is N2 by N1? N21. N2 by N1 is N21. So here we can write here 1 by F is equal to what? 1 by F is equal to
minus
Into
1.
minus one,
N2 1
into 1 by R1 minus 1 by
minus 1 into 1 by R1 minus
1 by R1.
1 by R1.
Lens maker formula done.
Lens maker formula. How can you say lens maker formula? I will tell you. See, if the lens is formed like this, suppose this is a glass, like a huge glass, spherical glass. If you are taking only one part out of it, the radius of curvature will be R. Sometimes it won't be like that. It will be like this, part of two spheres. This is R1, this is R2, radius of curvature is R2. That is why we say here R and R. Understood? Now, my question is from optical fiber. I am connecting my optical fiber to this now.
Yes.
Earlier in the glasses, suppose if you see like aged people, like 50, 60, they have bifocal lens. They have bifocal lens. Suppose this lens is there, like they used to have a line like this before. This is denser, and this is little dense. Maybe if it is 1.52, this is 1.58, something like that.
Then the concave lens. So here we have concave lens.
Yeah, sometimes it is like that, sometimes it is like this also. It's like
Like
this.
this, yeah.
Sometimes
Usually
it is
it's
or
like
sometimes
that.
it is like this also.
Yeah.
Two are there. But now in the glasses you don't see that. Even it is bifocal, it's not there. Right?
It's like 1, 2, 3.
They applied magic and then they made it invisible.
It's like the in the middle.
It is,
Like 1,
it is,
2, like
no. What they have done, you know, like
Fixed there,
in
right?
optical fiber, in
yeah.
optical fiber there is a concept. Like core and cladding is there, right? This core and cladding, but it is completely different. One, this is 1.52, this is 1.48.
Also they did
So
this
what they do, what they are doing here is, what they are, I will tell you. No, while doing experiment with the fibers, they did one thing. How they did, you know, 1.48, 1.49, 1.50, 1.51, 1.52, one that like this. Means not directly they are developing the fibers of this different you know, like it's not like optical fiber it's perfect, but now the refractive index is changing from 1.48 to 1.52 here. Got it in the lens. So the people who are wearing this one first and now they are using this one, it's difficult for them. Like 1 week, 10 days, it will be like difficult. But after that, they get used to it. But that is also an advantage to the eye. Why? What the experiment they had an ophthalmologist, they did the experiment. What was the experiment? You know.
The eye will be able to focus more.
Now they have to see like this. You know, in the or like sometimes the eye has aberration. They become itchy. Like you know, the point is increasing instead of decreasing or to be remaining constant. It is still increasing. Why? Because this margin is becoming headache for the eye. But using these lenses, like this type of
There
lenses,
is no
ah,
like mark.
there is no margin. So when the eye is moving down, automatically the density of the refractive index is slightly increasing or decreasing ratio. Going up to down, increasing, down to up, increasing. So you know, eye is getting used to it now.
So there's one more thing, compressed lens. How is that?
I don't know.
Like, for example, if lens has a 5 or 6 power negative, they compress. It will be a thick lens, but then nowadays it's really thin. How do they do that?
This is completely crystal formation. You studied in chemistry, right? The crystallization. But it is expensive, right?
Yeah, it's expensive.
Why it is expensive? Actually, there are naturally cooled lenses and artificially cooled lenses. When they form the glass, it is very hot. They immediately cool it because you cannot wait for actually natural cooling will take 6 months. No, the lenses which are used in telescope, especially for the research purpose and all, it takes 6 months to 1 year to form the lens. They make one. There is a dye in that they put that liquid silicon and they leave it. It should cool naturally so that all the crystals will go and slowly they get that locations.
Yeah.
Otherwise, in our normal glasses, it's not like that. Normal glasses, they immediately cool it. The cooling process. What is it called? The cooling of a glass. What is it called? Quenching. That process, quenching is taking place very fast. It's a quick process. But naturally cooling will take time. So what they do is, the dye is made in such a way that the whole liquid slowly it compresses. Slowly the pressure is removed. Slowly, and automatically what happens? It comes closer and closer. That they can do it.
So then in artificial lenses, air will be trapped.
No, there is no trap, no air trap. That also pressure is removed.
Okay.
But quickly.
So the formation won't be that good.
But still it is good.
Sir, this optical thing, you can't bend it, right? What is in use?
Yeah, we are bending it, right?
No, sir, like, what is in use? You can't bend the wire, right?
No, it is in use. We can now
So, but they want that
there is a condition for that. Don't bend like 90 degrees.
So it's bending it.
Don't bend like this.
Don't go sharp bend.
Sharp bend. Smooth bend is okay. Because the waves in that are high frequency. High frequency means low wavelength, right? It is in how much? Low wavelength means nanoseconds or nanometers. That won't affect that much. There were losses actually. There were optical fiber losses for there earlier when they manufactured all these things. Now they have designed in such a way that little bending is okay. But these fibers, no, this fiber here it is a bending. Otherwise, on the road it is not like this. On the road it is like a fiber. There are so many fibers, and this is like there is a hard cable. You can't even bend it this much. Not even this much also. Have you seen that cables like they dig and they put the cables, black color cables, or orange, dark orange color or brown color cables? You can't even bend it. They big on the truck. They bring it and it is on the, you can't bend it. It's very difficult. It's very hard. Actually, only here they are doing that. That experiment only little, no. That only small piece of pipe. That's this much only. On the road, it's not happening like that. It's a straight actually. They put the pipe and it is completely straight. There is no bending actually. Okay. So there's a bending losses actually. No. Okay. So this completes the second derivation. Now we'll go to the third derivation. Do something.
She might not send it. She sent the second.
Okay. We will do the power of lens derivation then. Quickly we'll go to the next. Are you tired?
She said this for the other chapter also. We don't want to do that.
But is it clear? But no, he replied. No.
On morning 8 years.
Yesterday it got over at 3 o'clock.
3 o'clock.
From morning 7:30 to 3 o'clock. This one is a job. You also sat here from 3 o'clock to 9 o'clock. Right?
Yeah. Now when a parallel ray is made to incident on the lens, it converges to a point. Okay. No. Now this is delta. Okay. So we have This
That
is
is
h.
angle of deviation? No, right?
No, just bending. That is converging or diverging of a lens.
Okay.
The ability of the lens to converge or diverge is said to be power of lens. And this is what f. It converges to focal point. So tan delta equal to what? H by f. Tan delta equal to h of 1. So if h is equal to 1, if h is equal to 1, what will happen? Tan delta will be equal to
1 by f.
1 by f. Tan delta is equal to 1 by f. And even angle is very small, then we write delta equal to 1 by f.
Therefore, delta
So the
is
delta is power.
power.
Okay. P is equal to
1 by
that.
f.
P is equal to 1 by f.
1
The
by f.
reciprocal of the focal length is said to be power. Yeah. And it is positive for which lens?
1 by f.
Positive for convex and negative for
1 by f.
okay, very good. And keep that in the mind. You have to convert centimeter to meters. Okay.
Yeah, I can see that.
Whose handwriting is that? Oh, writing you have to. And lens, make it thicker, thin, as thin as possible. It's very thick. No? But draw on lens way once again. Almost not try a straight line. No.
And then over here, right when she started compound on this, I know this one. And then she made me do this. I was like, what the hell is this? I don't know this one. I'm sleeping. And then I started sleeping. See that effect.
Yeah, person sent the photo of you.
Nice.
Yeah, you were
Keep it straight.
you were looking
Practice with the pencil. You'll get it. You know there is optical engineering actually. Optical engineering. Now by bits learning, you have optical engineering also. Where we design the lenses. It's not a, it's a bar. It's a study.
So, like, what is the duration of the course?
Like is it
4
engineering?
years ago.
Like 3 or 4 years. It's not like only completed lenses, you know. We study so much in that. The designing of microscope, telescope, many things.
This is
You know
fine to a limit.
You may ask, so what is a telescope? The biggest telescope? Sorry, microscope and telescope. Microscope is in IIT Madras and IIC Bangalore in India. 2 crore Indian rupees. Very in the year 2000. In the year 2000, the cost of that was 2 crore Indian rupees. I don't know how much it is. No, it is we said SEM and TEM, scanning electron microscope and transmission electron microscope. To understand that, you should understand the nature of matter and radiation. You know, Gerber and Dyson experiment. From there only it started. That experiment, why it is important? Because it gave rise to all the creativity for designing SEM and TEM. SEM is scanning electron microscope, TEM for transmission electron microscope. Instead of using light rays, we use electrons also. Okay, so that is how that was designed, and we can magnify the size of the image will be maybe around 1 million times. So where it is used, especially for microscopic, to study the microscopic particles, we use that. Okay, and you are not supposed, you just have to give the sample, they will give the output. You cannot use it. Actually, it's like a big room, and there are trained people for that. Just give the sample, they will give the output to you. You are not supposed to enter that. It has a very, very fine alignment. Very, very fine alignment. If you just touch it, it's gone. Even when we went to IIT Madras for a training, even if you touch it, you will get a sound. Airproof, they are like have air holes there. You just touch it, you will get sound. So that's what. So you cannot even touch also. That much alignment is there. Small alignment is gone. Then again to adjust that much, it will take so much of time. So that's the thing. That's about confocal and confocal is like lenses we use. There also magnification is very, very high. And telescopes, if you ask me, the biggest telescope is now China. Where it was in Mexico. Now China recently have made one. If you go to China Pavilion, you can see the telescope also. China Pavilion, you can see. In Mexico Pavilion also, you can see that.
Where?
It is there.
Yeah, it is there, but where in the expo? I went there.
China Pavilion.
Yeah, top or somewhere.
Yeah, first floor, I think. They have the designing of the telescope.
Oh yeah,
Biggest telescope
I
is there.
remember.
Generally in Mexico it was there. It is one of the largest one. It should be generally more placed on the mountains so that they can gather more information. But this is the reflecting one. That is the refracting one. The Mexico one is the
still being
refracting.
built, yeah.
Huh? How did they take angle that much big lens, you know?
No, it's
They're very huge. How much is, you know?
still being built.
6
And when you saw it,
meter
it was
in
very
radius.
big, but now it's big.
It's 7 radius.
And that was naturally cooled. It will take 6 months time. Naturally cooled lenses. You have to take it there and you have to mount it out.
To look at planets.
You understand now? There is a space in
No,
the
but
space
that's
also
not
we have
possible, that's
telescope,
outside.
Hubble telescope, and one more is there. By India also they have Aryabhatta telescope.
So it has 7 kilometer radius.
Radius of telescope, right? In China.
Really?
Yeah.
7 kilometers. That means
Very
7
huge.
around 6 kilometer
We
big
can
lens.
play there literally in the disc. It's like a disc one, like a,
Yeah.
there's a reflecting one. That the one which they designed is a reflecting one.
So how far can it see?
Huh?
How far can
To
it see?
gather more information from the space.
That is fine, but
Huh?
So there is James Webb telescope, right? James Webb. What is that? James Webb telescope.
No, what is that?
It's an infrared astronomical telescope.
No, this actually why is more curvature, because to gather more information. The more the lens, the bigger is the lens, more information you can track. That's actual thing.
More clearer.
But the problem is again headache is with aberration again. But reflecting has less aberration. Refracting has more aberration. Reflecting as it is reflecting. But refracting has, because of the spherical and chromatic aberration. Okay, that's a problem. Reflecting is good, but again it has also disadvantages. Everyone has an advantage disadvantage.
Full lens.
Okay. That's all.
leave that playing
So,
on the glass.
Shall we stop here for today,
like
or
a glass
do you want me to continue?
round of 7
There's one more
kilometers.
derivation.
Yeah,
Okay,
oh
no,
my god,
you can
you
sit there
are
and
so
continue
sick.
from what derivation. Okay.
Sir,
We
we are here till
Yeah, you will be there till now.
yeah, till
Midnight.
9, 12 o'clock.
But yesterday your mom called like that.
He called me, she was like, no one can pick you after 9 o'clock this campus.
Today?
Yeah, no problem.
Okay, so that was about the telescope. Now we'll go with the combination of lenses is not there in our, but only the formula is there. The refraction radiation is there.
Yesterday, bus came at 8:50 itself, and I got it. Yeah.
No.
He was supposed to come at 9:10, but then came 20 minutes earlier.
Oh, but what time you came here yesterday?
We
3:30.
No, 3 o'clock.
3:30.
Yeah, 3 o'clock.
3:30.
Ah, here you mean while going.
Yeah.
Okay. Go with the next one.
James Webb telescope, right?
Yeah.
It is the most expensive science project ever made.
Was splendid.
US government 60 billion in the it's in a size building. And it's space.
A telescope.
A telescope. It's a reflective telescope. It began around 3 decades to build it.
So this started
From
basically from
1990.
so it's old
They
tech.
launched it this year.
So it's old tech.
No, it was so hard to build it. And every time they did some testing, like, they became one level down, like one use down. So they could again remake it out and they just put it back. So it again programs it 30 years.
I don't know, but like US government has so much patience to give the supplying scientists money, and scientists are like playing with the
It
money.
took so much debt, yeah. It took so much debt.
And same Indian government. If you want to do something, you need to pass
10
the
rupees, I'll give. Whatever you want. 10 rupees.
and they take so much tax that I think
But GST is what, 40%? I can't
no, but it's a lot though.
So what is GST percentage in India? Like, so what is GST percentage in India? GST, the tax in India percentage.
Percentage.
It is 40 or 30?
35. No, 30%. Which is different for different. State is different, center is different. There are two taxes. Interstate is different.
How much is per
There
day?
are two taxes.
There are two. GST, like GST state tax is there, GST interstate tax is there.
So
And GST center tax is there. There are three different taxes.
Three taxes.
Like suppose you are in example,
basically-
you are in Tamil Nadu. You pay 30% GST.
Yes, sir.
30% GST.
30%.
30% GST. That have included all the taxes in that. 30% GST. But the problem is if you are purchasing something from Kerala to Tamil Nadu, then you have to pay interest rate tax also.
40%.
I don't know how much it is. There's interest rate tax.
So, but then what is the use of the tax? Nothing we can see.
Huh?
What is the use of the tax?
Now what happened is I will give one example. What happened is
In between.